First teaching video for Math 107 College Algebra. In this video, we're going to take a look at different pieces of information we can get from the graph of a function. So we'll start with an example function of y equals the square root of 4 minus x squared. So we see that it's the top half of a circle. So there's different things we can do. One, we could get the value of the function at a point. In Desmos, that's a little bit easier if I put a number in there. So x equals 1, I can now click on that point and I see that the value at x equals 1 of the function is 1.732. So that's basic information I can get from a graph. But the other thing that I can do along that line, I'll get rid of that vertical line, is I can immediately see the range of this function. If you'll remember from previous courses, the range of a function is the set of all the y values that have a corresponding x value. So here, I can definitely see we go between 0 and 2. We actually hit 0 there. We actually hit 2 there. So the range here would be 0 to 2 inclusive. That's going to be the closed square brackets rather than the open parentheses and interval notation. So the range of a function is certainly one application of using the graph to find something. Another thing we could do is we can actually use the graph to solve equations and inequalities. So like 2x plus 3 2x squared plus 3. And then we have the other function y equals 5x plus 6. And let me move my graph so we can actually see things here. So first we can see where they're equal by finding the points of intersection. So that's there and there. And we see the graphs are equal, or functions have the same value, and so therefore the graphs intersect at x equals negative 0.5 and x equals 3. So we can use that to solve equations, but we can take it a step further and say that I want to know when 2x squared plus 3 is greater than 5x plus 6. So I look for where that's higher on the graph, and that's going to be this area. So values of x that are less than negative 0.5, and also this area, values of x that are greater than 3. So we can look at the graph to solve an inequality. Other things that we're going to talk about are going to be increasing and decreasing functions. So let me get a different example here. So we'll say the graph is increasing, looking at things going from left to right, if the graph is going up. So here, over on this side, less than negative 1.633, the graph is increasing. And also for x values greater than positive 1.633, the graph is increasing. And then we can say the graph is decreasing, it's going down as we travel from left to right. So between negative 1.633 and positive 1.633. Now, we can't talk about what the graph is doing where it changes directions, so these will always be open intervals if we were to write it in interval notation. We're not going to include any endpoints here because we can't say at negative 1.633 whether the graph is increasing or decreasing. But one further thing we can do is we see here the graph reaches a peak at x equals negative 1.633, and then it has a corresponding y value of 9.709. So we can actually say that 9.709 is a relative maximum of the graph that occurs at negative 1.633. Likewise, we hit the bottom of a valley at x equals positive 1.633 of negative 7.709. So we can say the graph has a local minimum of negative 7.709 at x equals 1.633. So that's various pieces of information we can get from the graph of a function. And we will discuss these details a little further on Thursday in class. I will see you then.